Okay, so today we'll continue our chapter 2. Okay, now we are going to look at the digital codes. Okay, so in this digital code, we'll learn about a few codes regarding the digital logics. Okay, so let's look at the introduction of the digital codes. Okay, so many digital device interacts with humans. Okay, so we have a lot of digital device out there. Okay, which is we are using it daily in our life. Okay, so we have a few things such as our household. Okay, dalam kita punya kereta pun ada digital device, and in fact, okay, all these digital device is widely used. Okay, so that it will help us in our daily routines. Okay, so in order to what we call here to communicate between this digital device and human is okay. Our humans prefer with a decimal system. Okay, kita sebagai manusia kita more preferable by using the decimal numbers. Okay, but computer or embedded system or any digital device prefer either using a binary numbers, hexa number, or octal numbers. Okay, most of the times, okay, this device here, okay, these computers, this embedded system, this microprocessor are preferred to use a binary numbers, which is asas 2, okay, base 2 system, or hexadecimal numbers. Okay, so what happened here is, okay, we need to use an encoding and decoding process in order to convert, okay, from decimal, okay, which is our inputs, okay, to the binary ataupun to the hexadecimal, and after that convert back to the decimal to display by using a digital codes or any conversion types. Okay, so let's look at this what we call here figures here. Okay, we have an input device. Okay, preferably. So this input device kita ambil for example, we have a calculators. Okay, so kita ambil kita punya calculators. So we have a input device here, which is our keypad from the calculators. Okay, that keypad from calculators are using the decimal number lah. Okay, because we human are prefer in decimal numbers. And then when you key in the whatever value, okay, that you're going to put to your calculator. So what happen here is, okay, that value will be translated to the binary numbers or hexadecimal numbers by using encoder circuits. Okay, so this encoder circuit akan tukar, okay, this value dalam decimal ke binary ataupun ke hexadecimal based on the what type of codes ataupun conversion type yang digunakan dalam encoder ni lah. Okay, and then after that, this processor here, okay, will do all the processing things lah. Okay, contohlah kamu kalau kamu nak buat penambahan, okay, if you going to do a subtraction, additional, okay, so this processor here akan takes all the values, okay, and do the processing, and then after that, the result will be displayed to the output device. Okay, so before the result displayed to output device, okay, it need to decode the back to the decimal number. Okay, dia perlu ditukarkan semula kepada decimal number. Kenapa? Sebab dekat sini the value is still in binary ataupun hexadecimal. So we need to convert back to decimal, and that value will be displayed to the calculator screen. Okay, so that we know that, okay, 1 tambah 1 we know, okay, we're getting a 2 kat situ. Okay, so this is the things lah. Okay, this is the things that we need to use here. Okay, encoder and decoder to perform the data conversion. So inside of this encoder and decoder, we have these digital codes lah dalam ni. Okay, we have a few digital codes, okay, to look at. Okay, so these digital codes dalam encoder and decoder ni can be divided into two types. Okay, dia ada dua jenis. Okay, satu we call it as a numeric. Okay, numeric codes. Okay, so for the first one we call it as a numeric. codes. Okay, so this numeric code involve of nombor saja. Okay, dia hanya melibatkan nombor saja. So well, that's why we call it as a numeric code. Okay, example of numeric code is such as a binary code, decimal, gray codes, and etc. Okay, then nombor dua, okay, we have a what we call as a alpha numeric. Okay, so this alpha numeric is a combination of nombor dengan alfabet. So that's why kita panggil sebagai alpha numeric. Okay, kamu ada nombor dan characters. Okay, alphabet characters. Okay, contoh alphanumeric is ASCII code, okay, ANSI code, and etc. Okay, later in the next slide, we are going to look at this numeric code and alphanumeric codes. Okay, so as I mentioned earlier, okay, we have few type of codes available. Okay, first we call it as a BCD codes. Okay, so this is a numeric code. Grade code pun numeric code. Then we have the ASCII code. So this is a alphanumeric code sebab it consists of nombor dan alphabet characters and some symbols. Okay, inside of ASCII there are some symbols that we can use. Okay, then we have a Unicode. Okay, yang ni pun sama juga, similar to ASCII code, tapi dia punya character lagi banyak lah. Okay, which is it can support the Chinese character, Arabic character, and etc. And then we have last but not least ABC, DIC codes. Yang ni pun another alphanumeric codes. Okay, let's look at the first digital code that we're going to look at. Here is a BCD codes. Okay, so this BCD code ataupun kita boleh panggil dia sebagai binary code decimal. Okay, so this is the simplest interface between binary and digital system. Okay, so each decimal digit use 4 bits. Okay, so setiap decimal value akan diwakili dengan menggunakan 4 bits boundary. Okay, so each 4-bit group is treated as separate binary numbers. Okay, contoh. Okay, you have a 0. So kalau tukarkan dia kepada BCD code, 0 is a 0, 0, 0, 0. Okay, if you're going to translate nombor 8 kepada BCD, okay, the value is 1000. Okay, macam mana nak dapat ni? Okay, we can use the 8421 method. Okay, so 8421. Okay, which is quite similar what we have done masa kita nak tukar daripada binary ke hexadecimal. Okay, sebelum ni kita pernah buat itu kan, yang 4-bit boundary. Okay, yang ni pun sama. But yang ni, what happen here for the BCD, okay, kamu tukar base 10, okay, kepada BCD code. Okay, previously what we have done is base 16 to base 2 ataupun base 2 ke base 16. But now base 10, okay, which is your decimal number, now you're going to convert it to the BCD. Okay, binary code decimals. Okay, contoh. Okay, let's your calculator kat sini using the BCD codes. Okay, so now we are going to look at what is the value that will go to your processor after the encoding process. Contoh, kamu nak masukkan nombor 641. Okay, you're going to press 641 to your calculator. Okay, so what happened here? Okay, so nombor 641 ni adalah dalam decimal. So it will translate to BCD code dahulu. Okay, how to do that? Okay, mula-mula each of this decimal digit ni akan ditukarkan kepada 4-bit boundary. Okay, so now we're going to find out what is the BCD code representation for nombor 641. Okay, macam mana nak buat? By using the 8421 method. Okay, kamu ada 641. Okay, so yang ni akan ada 4-bit boundary 8421. 8421 8421. Okay, so this is a base 10, and then you press calculator. This calculator using a BCD. Okay, so what you're going to do, kita nak find out lah what is the number. Okay, so nombor 1, okay, to get number 1, okay, so 8 akan dapat 0, 4, 0, 2, 0, and this one will get 1. Okay, so this is for to represent number 1 lah. Okay, dalam BCD. Okay, nombor 4, 0, 1, 0, 0. And nombor 6, 4 tambah 2 is 1, 1. Okay, 6. And the rest kamu letak 0. So this is the value that will, okay, that will translate by the encoder. Okay, so kamu masukkan 641 pada kamu punya calculator, and your calculator using the BCD. So this is the value that will go to your processor. Okay, and the processor know that this 0110, 0100 and 0001 ni adalah value 641. Okay, so this BCD, okay, so this BCD code also known as a BCD 8421 code because the number indicates as the weight of each bit. Okay, so next, okay, so this is the step lah. Okay, how to convert from BCD to decimal and how to convert from decimal to BCD. Okay, previously kita dah tengok daripada decimal nak convert ke BCD. Okay, now we have the BCD. Okay, we are going to convert kepada decimal, in which sekarang ni kita dalam proses decoder. Okay, kamu dah ada result, hasil tambah tu kamu dah dapat, and then you going to translate back to the decimal number. Okay, by using the decoder. So now we are going to use the digital code yang kita nak guna sekarang ni adalah BCD. So how to do that? Okay, to do that, okay, step number 1 sama juga. Okay, break the BCD code into 4-bit groups. Okay, starting from LSB lah. Okay, starting from the least significant bit. Kamu grupkan dia kepada 4-bit boundary and replace each 4-bit group with its equivalent decimal. Okay, by using the 8421 method, kamu dapatkan nombor decimal dia. Okay, contoh. Okay, convert this code, BCD code 0011 0101 001 to decimal. So how to do it? Okay, mula-mula apa kena buat? Okay, so
bagikan 4 grup.
Okay, so identify dulu kamu punya LSB. Okay, grupkan dia kepada 4 bit boundary. And then after that, by using the 8421.
8421.
Okay, so you put the weightage here and then get the decimal number. Okay, so yang ni akan jadi 1, yang ni akan jadi 5, and this akan jadi
3.
Okay, so this is the value in decimal. Okay. So any question up until here? Ada soalan tak? Okay, so this is for the BCD lah. Okay, next we are going to look at the another code. Okay, numeric code called gray code. Ada soalan tak untuk BCD? Okay, BCD is more straightforward lah. Okay, di mana kita hanya guna dia punya this method ya, 8421.
Clear.
Ada soalan? Okay, kalau tak ada soalan, now we are moving to the next slide. Okay, which is gray code. Okay, so what is a gray code? So gray code is a non-weighted code. Okay, so gray code ni tak guna weight macam BCD tadi. Okay, BCD tadi kita ada weightage. Okay, so we using a weightage to get the code untuk dapatkan dia punya code. But gray code is not. It's not use a weight to get the code. Okay, so only a single bit change from one code word to the next sequence. Okay, so setiap sequence tu hanya 1 bit saja yang berubah. Okay, contoh yang ni tadi. Kalau kamu tengok ni, 0000 nak tukar kepada nombor 1, bit yang ni bertukar. Okay, yang bit yang ni berubah. Okay, but untuk tukar daripada 1 kepada 2, okay, 2 bit yang berubah. Okay, which is yang ni. Kamu tengok daripada 01 10. So 2 bit berubah. Okey, nak pergi ke nombor 3. Sekarang ni bit yang mana berubah? Yang ni berubah. Okey. Dari 3 nak pergi ke nombor 4, 3
3
bit
bit
berubah.
berubah.
Okey. But untuk ini untuk BCD code. Untuk gray code from nombor 1 nak pergi ke from 0 nak pergi ke nombor 1, 1 bit je berubah. 1 ke 2, 1 bit juga yang berubah. Okey, dia tak lebih. Only 1 bit change at one time from whenever you're going to change from number 1 to number 2, number 2 to number 3 and etc. Okay, so that what we call it as yang ni lah, only a single bit change from one code word to the next sequence. Okay, so it is a good to minimize the chance of error. Kenapa? Sebabnya hanya satu code saja yang berubah pada satu-satu masa. Okay, kalau kamu tengok ni, so this is decimal number, so this is the binary, this is the gray code. Okay, untuk kosong, gray code kita 000. Bila 1, okay, so bit yang ni berubah. Kamu tengok yang bit yang ni berubah daripada 0 kepada 1. Okay, untuk nombor 2, okay, bit yang ni je berubah. Okay, only 1 bit berubah yang ni. Okay, which is it change from 0 to 1. Nombor 3, okay, when going to display a number 3, okay, only 1 bit change. Okay, this bit change 1 kepada 0. And then if you're going to display number 4, okay, bit yang berubah sekarang ni bit yang ini. This bit yang berubah, which is 0 kepada 1. So perlu tak kamu hafal yang ni? Tak perlu hafal. No need to remember this code here. Kenapa? Sebabnya kita ada cara macam mana nak dapatkan decimal representation for gray code. Okay, macam mana nak convert daripada decimal ke gray code and daripada gray code ke decimal. Okay, so no need to remember this gray code lah. Okay, for each of this decimal value. Okay, so now we're going to look at macam mana nak tukar daripada binary, daripada decimal kepada gray code and daripada gray code ke decimal. Okay, so the gray code, okay, nak tukar daripada decimal ke gray code, okay, decimal to gray code, okay, what you need to do is sebelum kamu tukar daripada decimal ke gray code, kamu kena dapatkan dahulu, okay, kat sini, kamu kena dapatkan dulu dia punya binary number. Okay, once you get the binary number, then after that you can go, okay, you can get the gray code. Okay, so this is the dia punya ni lah, dia punya step. Okay, the first thing here, okay, you need to tukar dulu nombor decimal kamu kepada binary, and once you get the binary number, then after that you need to convert to gray code. Okay, so let's look at this how to convert daripada binary. Okay, let's assume lah kita dah convert dah kita punya decimal number ni kepada binary. Okay, so now we're going to look at how to do a conversion daripada this binary number kepada gray code. Okay, so the first step, the most significant bit, okay, your MSB in the gray code is the same as the corresponding MSB in the binary number. Okay, means that first, okay, kamu cari dahulu dia punya MSB. Okay, contoh kamu ada this value 10110. Okay, 10110. Okay, so this is a binary number. Okay, now you're going to convert to gray. Okay, mula-mula this value here kita cari dulu dia punya MSB. So this is the MSB, the most significant bit. Okay, ataupun kita the leftmost bit in the binary number. Okay, so what you're going to do? Yang ni kamu copy dahulu value dia. Alright. So kamu copy. Contoh kalau nombor kat sini kosong, kamu copy lah kosong. Kalau 1, kamu copy dia sebagai 1. Okay, next. Going from left to the right, okay, daripada kiri ke kanan, add each adjacent pair of binary code to get the next gray code and discard carries. Okay, ini penting. Okay, daripada kiri ke kanan, tambah dia punya adjacent pair. Okay, so this one here, the adjacent pair is 1 tambah kosong lah. Okay, and bila kamu tambah this one, okay, 1 tambah kosong berapa? 1. Okay, so bila kamu dah tambah, so kamu akan dapat 1. Okay, next, tambah lagi. Yang ni tambah yang ni akan hasilkan yang ni.
1.
Okay, ya. Yang ni tambah yang ni akan hasilkan kat sini. Yang ni tambah yang ni akan hasilkan sini. Yang ni tambah yang ni akan hasilkan sini. Okay. So sekarang ni kita tambah 0 tambah 1, 1. Okay, next kita tambah lagi 1 tambah 1.
0.
1, 0. Kamu dapat 1, 0 kan? 1 tambah 1, 1, 0. Tapi kita discard carries. Kita hanya ambil dia punya sum. Okay, remember back semalam? 1 tambah 1, kamu akan dapat 1, 0. Yang ni sum, yang ni carry. So yang ni kita tak nak. Kita hanya ambil
Sum
sahaja.
Okay.
Okay, so 0. So tambah lagi 1 tambah 0, so kamu akan dapat 1. So this is your gray code. Okay, to represent number 11101. Okay, so to represent number yang ni 10110. So the gray code is 1101. Okay, so let's check betul ke tak. Okay, kita ambil 1. Okay, sekarang ni kita nak ambil nombor 7. Okay, nombor 7 kamu tukar kepada binary. So this is the binary number untuk nombor 7. 0111. Okay, so sekarang nak dapatkan dia punya gray code. Okay, so first yang ni kita copy 0. Lepas tu tambah 0 tambah 1, kamu akan dapat 1. Yang ni tambah 1 tambah 1, kamu akan dapat 1, 0.
1, discard carry.
Okay.
0.
So 1 tambah 1, kamu still dapat 1, 0. So kalau dia discard carry, kamu dapat. So this is
100. 0100. Ya, betul.
Okay, so betul. Okay, so this is how to get lah. Okay, how to convert daripada decimal number kepada gray code. Okay, mula-mula tukarkan dahulu kepada binary, and then after that you need to do this step lah, this formula ya. Okay, copy dulu MSB, and then add the adjacent pair. Any carries you discard. Okay, so that is from nak tukar kepada gray code. Okay, from the binary to gray code. Okay, now we're going to convert back. Okay, kamu ada gray code. Okay, kamu nak decode supaya kamu dapat binary number or decimal number. Okay, so macam mana nak buat? Okay, from gray code to binary conversion. Okay, first, the most significant bit, okay, sama juga, MSB, in binary number, okay, is the same as the corresponding bit in the gray code. Okay, maksudnya kat sini, sama juga, kamu cari dahulu MSB, and lepas tu nak buat apa? Copy semula. This MSB. Okay, and then next, add each binary number bit generated to the gray code bit in the next adjacent position. Okay, discard carries. Okay, sebelum ni kita tambah yang sebelah ni kan. Sekarang ni yang sini kamu kena tambah dengan yang atas. Okay, yang binary number yang kamu dapat ni kamu kena tambah dengan kamu punya
Atas.
gray code dekat atas ni. Okay, and then dia akan produce yang ni lah. Contoh, kita tengok contoh. Okay, kamu ada 11011. Okay, so this is a gray. Kamu nak tukar dia kepada binary. Okay, base tu. Okay, mula-mula dapatkan dulu MSB.
SB. 1, 2.
Copy. Okay, and then kamu tambah dengan yang ni.
1 tambah 1, 10.
Okay, 1 tambah 1, 10.
1, 0. Discard carry.
Carry, so kamu akan dapat Kosong.
Kosong.
Okay, so tambah lagi.
Kosong
Kosong tambah kosong, kamu akan dapat kosong. Tambah kosong satu,
Tambah
kamu
satu,
akan dapat
satu.
satu. And tambah yang ni, 1 tambah 1, kamu akan dapat 1 kosong. Kamu discard sekali, kamu akan dapat.
Kosong.
So, this is the value lah dalam binary. Okay, so let's check. Kita ambil dari table ni. Contoh kita ambil yang ni lah. 12. Okay, yang ni. 1010. Okay, so we're going to find out what is the 1010 represent in the decimal and binary. Okay, so kamu ada 1010. Okay, so this is your MSB.
MSB turun.
Copy balik. Dapat
Balik.
1.
1 tambah kosong. 1.
Okay, so 1 tambah kosong, kamu akan dapat 1.
1
tambah 1, kamu akan dapat 1 kosong, which is this is a kosong. And then kosong tambah kosong, kamu akan dapat
kosong.
so this is asal semula, which is 1 1 kosong kosong. Okay, lepas tu 1 1 kosong kosong ni kamu tukarlah dalam decimal. Okay, by using the darab dia punya weightage 1 2 4 8, so kamu dapat 8 tambah 4 12. So this is in decimal number. Okay, any question up until here? Okay, contoh, saya bagi contoh. Okay, kadang-kadang soalan dia tricky sikit. Okay, so contoh. Okay, macam mana nak buat? Okay, kamu ada 16 BCD nak dapatkan dalam grade.
Tukar dulu pada binary. BCD.
Okay, so yang sorry. Bukan 16 BCD, salah. Okay, BCD dia dalam bentuk ni. Sorry tersilap. Okay. 1 0 edit tak boleh lebih ni 8. Okay, betul. 1 0 0 1 0 1 1 0. Okay, contoh. Saya buat tempat lain lah, bagi besar sikit. Sekejap. Yes, stop dulu ni. Okay, boleh nampak ya saya punya screen? Okay, contoh kamu ada 1 0 0 0. Sekejap, bukan 0. 1 0 1 1 0. Okay, so this is a BCD. Okay, now we're going to find out what is the gray code. Okay, macam mana? Macam mana nak buat yang ni? Adakah kamu boleh directly dapatkan terus dia punya gray code? Ataupun kamu kena ada a few step sebelum kamu dapatkan gray code dahulu?
Tukar dulu kan?
Okay, so jawapan dia kamu kena tukar dulu. Sebab yang ni BCD. Tadi kita belajar tadi, nak tukar kepada gray code, kena dalam binary, betul tak? BCD dan binary dua benda yang berbeza. Okay, so you need to tukar, even though kita nampak ni dalam bentuk 1010, which is kind of the binary, tapi yang ni dalam BCD. Okay, which is different lah from the binary number. So what you need to do here, kamu dapatkan dulu dia punya decimal. Okay, sebab daripada BCD kita boleh dapatkan decimal. Okay, so dapatkan dulu dia punya base 10. Okay, Once kamu dah dapat base 10, then after that, tukarkan dia kepada base 2. Okay, dapatkan dia punya binary number. And after that, barulah kamu dapatkan dia punya gray code. Okay, so kita tukar dia kepada base 10 dulu. Macam mana nak tukar base 10 daripada BCD? By using 8421 method tadi kan? Okay, so 8421, 8421. Okay, so 8 tambah 1, 9. 4 tambah 2, kamu dapat
6.
6.
96.
Okay, so this is dalam asas 10. Okay, so 96 tukar kepada binary. Macam mana nak tukar? Okay, kamu kena darab dia punya weightage lah. 1, 2, 4, 8, 16, 32, 64, 128 dan lebih lah. Okay, so 128 ni kosong. Okay, 64 perlu ada. Okay, so 96 tolak dengan 64, kamu masih ada lagi 32. Okay, so 32 ada kat situ and the rest kamu letak kosong. So this is the binary numbers. Okay, so once kamu dah dapat binary numbers, barulah kamu dapatkan dia punya gray. Okay, macam mana nak dapatkan dia punya gray code? Okay, first, identify dahulu dia punya MSB.
MSB.
Okay, so MSB yang ni sekarang ni kita ambil yang 64 ni lah. Yang kosong ni just ignore je. Tak perlu ambil pun tak apa. Kalau nak ambil pun jawapan dia still sama juga nanti. Okay, so kita kita try
64 ni.
64 dahulu ya. Kita try 64 dahulu and then after that kita try yang 28. Okay, so yang ni saya. So this is MSB. Okay, tadi 1100. Okay, so yang ni dia punya MSB. Okay, copy balik semula. And then tambah dia punya adjacent pair. Okay, 1 tambah 1 kamu akan dapat 10. Discard carry.
Kosong.
Okay, 1 tambah 0 kamu akan dapat 1. Okay, 0 tambah 0 kamu akan dapat 0. 0 tambah 0 kamu akan dapat 0. 0 tambah 0, 0 tambah 0 kamu akan dapat 0. Yang ni kamu punya gray code. Okay, let's kita ambil yang ni, kita ambil yang ni lah. Kita include dari 128. Okay, so copy.
0.
0
Tambah 1.
0 tambah 1 kamu akan dapat 1. 1 tambah 1 kamu akan dapat 1 kosong.
1
0.
1 tambah 0 1.
0.
0.
Okay. 0.
0.
0.
0.
and
0.
0. Okay, so jawapannya sama juga. Sama ada kamu ambil yang ni ataupun yang ni. Okay, tapi make sure lah. Okay, kena pastikan kalau yang depan ni 1, kamu kena include yang ni. Kalau tidak, salah. Okay, if the 128 ni, kat bit ni ada 1, so kamu kena include. Kalau ni kosong, tak apa, kamu boleh discard saja. Okay, so yang ni penting ni. Okay, selalunya treat dia kat sini lah. Okay, dia bagi BCD, tukar grade. Okay, selalunya ada student, okay, dia terus directly. Okay, yang ni copy 1 and then tambah macam biasa. Which is salah lah. Kamu punya grade code. Sebab yang ni BCD, not binary numbers. Okay. So that is for the grade code. Okay, kita dah habis pasal grade code. And then now we are moving on to the next slide. Okay, sekarang kita nak tengok alphanumeric codes. So in complex digital system, okay, such as your computers, your smartphones, your embedded system, okay, must process not only numeric data, but also alphabets, okay, symbols. Okay, you have the punctuation marks, okay, question marks, and then you have a lot of symbol macam slash, greater than, smaller than, benda-benda tu. Okay, and other symbols. Okay, those, okay, to represent these numbers and alphabet characters, which is the letters and the symbols, a code called alphanumeric code is needed. Okay, kalau numeric dia akan display nombor saja. Kalau alphanumeric dia akan ada characters, alphabet characters, numbers dan symbols. Okay, so at minimum, the code must represent 10-digit decimal numbers. Okay, yang ni paling minimum lah. Okay, daripada 0 hingga 9. Okay, kamu ada 10 decimal number, 0 hingga 9. And 26 letters, which is daripada A to Z. So, A to Z ni mungkin all the letters here is capital letters. Ataupun semuanya huruf kecil. Okay. So, you need to have 26 letters. And total kat sini 10 tambah 26, 36 characters. Okay. This is paling minimum lah. Okay. Kalau kamu nak ada, kamu punya codes consist of decimal number. And then, letters ni kena ada capital letter, small letter. So, kamu kena tambah lagi 26. So, total is 62 characters. Okay, so 6 bits are needed in the code that represent the numbers and letters. Kenapa? Sebab 5 bit is not enough. Okay, kenapa 6 bit? Kenapa bukan 5 bit? Okay, contoh. Okay, so this is a 5 bit. Contoh kalau kamu letak 5 bit ni semuanya 1, 1, 1, 1, 1. Okay, kamu tukarkan dia ke dalam decimal. Okay, 16 tambah 8. Okay, so 16 tambah 8 kamu dapat 24. 24, 28, 29, 30, 31. So, kamu hanya ada up to 31. Okay, which is daripada 0 hingga 31, kamu total 32 karakter saja yang kamu boleh support. Okay, kenapa? Okay, sebabnya tadi kita total up kena ada 36 characters. Okay, tapi kalau kamu pakai 5 bit number je, okay, so characters yang kamu boleh support hanya 32, which is daripada bit 0 sampai bit 111. Okay, so bit 0 yang ni lah, 0, 0, 0, 0, 0. So, contoh 000 ni represent nombor 0. 0, 0, 0, 0, 1 will represent number 1. And 111 ni akan represent huruf bukan Z lagi lah ni, sebabnya baru 32. 32 mungkin W ke ataupun U, mungkin U lah. Okay, so tak cukup lagi. W, X, Y, Z, kamu kekurangan 4 lagi characters. Okay, so 32 bit, okay, sorry, 5 bit tak cukup. Okay, 5 bits data tak cukup. Kenapa? Sebab 2 kuasa 5 sama dengan 32. Okay, so tak cukup. So, kamu kena ada 6 bits. Okay, kalau 6 bits, then you... Okay, kalau 6 bits, 1, 1, 1, 1, 1. So, 1, 2, 4, 2, 4, 5, 6. Sorry, saya tambah sini lah. Okay, 1, 2, 4, 8, 16, 32 and this 64. So, kamu dah ada total of 64 characters. Okay, so dapatlah kamu nak displaykan alphanumeric of this 32 characters kat sini, which is ada 10 numbers and 26 lagi character daripada A to Z. Okay, so kita kena pakai at least 6 bit numbers. Okay, and ASCII is the most common alphanumeric code. Okay, ASCII ni yang paling common kita guna. Okay, which is kalau kamu tengok dekat kamu punya keyboard, that is your ASCII code. Okay, so let's look at the ASCII code. So ASCII is the abbreviation of American Standard Code for Internet Interchange. Okay, so it used in computers and any electronics equipment. Okay, by default, all of our computer are using the ASCII. Unless kamu guna komputer yang nak tulis Arabic characters ataupun Chinese character ataupun yang Japanese character, so that one kena pakai another code, bukan ASCII code. Okay, ASCII code tak support this Arabic character, Chinese character, Japanese character, Russian character, and etc. Okay, so most computer keyboard are standardized with ASCII code. Okay, when entering a letter, a number or control command, the corresponding ASCII code goes to the computer. Okay, every time you press Q, okay, a certain code will be sent to your processor, and your processor know now you are sending a Q. Okay, contoh kalau kamu press enter, a certain code will be sent to your computer, and now your computer know that okay, now this guy pressing an enter. Okay, so the ASCII has total up to 1 to 8 characters. Okay, dia ada total 128 characters, including numbers, okay, alphabetic, okay, alphabet character, either capital letters or small letters, okay, huruf besar, huruf kecil, and then symbols. Okay, tambah, tolak, bahagi, darab, hand symbols, then you have slash 5, double slash, home page, page down, enter, space bar, and etc. Okay, and so 128 can represent by 7-bit binary code. Okay, 7-bit enough to represent 128 character. Okay, so bila kamu tambah 7-bit, okay, if you have the 111, okay, so 1, 2, 4, 8, 16, 32, 64. Kamu tambah semua sekali ni, okay, kamu boleh dapat total of, so next is 128. Okay, so this is a 127. Tapi kamu jangan lupa, kamu ada nombor kosong, which is total is 128. Okay, so bolehlah 7-bit dah enough untuk support ASCII code. But most of the time, okay, can be considered as a 8-bit. Okay, boleh juga guna 8-bit, tapi the bit ke-7 ni, which is your MSB, always become 0. Okay, so this ASCII can be divided into non-graphic commands. Okay, contoh, the first 32 ASCII character are only for the control purpose, seperti null, line feed, escape, enter, start of the text, end page, print screen, and etc. Okay, so this is what we call it as a non-graphic commands. And next is a graphic symbols, which is a letter of alphabetic, either lowercase, uppercase, 10 decimal digits, punctuation signs, other commonly used symbol. So this is the ASCII table. Okay, so kalau kamu tengok kat sini, this is the table. Tak perlu hafal table ni. Okay, kalau nanti dalam test, dalam final exam, tanya pasal ASCII code, okay, so this table will be given to you. Okay, kamu cuma tahu macam mana nak guna sahaja. Okay, so tak perlu hafal this code. Code yang ni tak perlu, this table tak perlu hafal. Okay, so kita kena tahu bacaan dia, macam mana nak baca. Okay, kalau kamu tengok sini, this is bit 3 hingga bit 0. Okay, tadi kan kalau kamu lihat, kamu ada total of 7 bit. Okay, bit 0, 1, 2, 3, 4, 5, 6. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, kalau 8 bit, bit ke-7 ni always 0. Okay, so now we are going to focus on this bit here. Okay, in color, saya tukarkan bit yang ni 4 hingga 6. Okay, which is represented by this column here. And 3210 is represented by yang ni. This column. Okay. Contoh. Okay, so sekarang ni kamu nak kamu press nombor 0, okay, from your keyboard. Okay, so the bit that will go to your processor is 011. Okay, kalau kamu press 0. Okay, contoh ya, kamu masukkan 0. Okay, the bit yang akan keluar kat sini yang akan dihantar ke what we call here your punya processor is 011 and then followed by 0000. Okay, you see ya. Okay, ni 0 Okay, so 011 which is this you need to fill in the bit 654 lah, 011. And then this one here is 000. So this is the bit that will represent nombor 0. Okay, contoh. Next, kamu nak tekan tambah. Okay, so this is the tambah. Okay, for the symbol tambah, okay, the ASCII code for symbol tambah is 010 followed by 1011. Okay, that is the ASCII code for tambah. Okay, kamu nak tambah 0 tambah dengan 9 contohnya. Okay, next, nombor 9, ASCII code untuk nombor 9 adalah 011 followed by 1001. So that is a nombor 9. Then after that, okay, so CPU tahulah, okay, so kamu nak tambah 0 tambah dengan 9. It produce a result 9. Okay, so dia akan hasilkan 9 which is the value here is 011 1001. So this value here will go to your decoder and decoder will translate. Okay, now it will display nombor 9. Okay, so tak perlu hafal, hanya tahu macam mana nak baca this table. Okay, any question untuk table ni? Ada soalan tak? Okay, saya bagi another contoh. Okay, so sekarang ni kamu press smaller h. Okay, kamu nak press lowercase h. Okay, so this is the h untuk lowercase. Okay, so the ASCII code for small h is 110 and then 1000. Right? Itu saja. That is for the ASCII code. Okay, so whatever you press on your keyboard, it will translate to ASCII code based on this table here, and then dia akan hantar ke processor, and the processor know, okay, you're going to press this small h. Okay. So next we are going to look at the Unicodes. Okay, so Unicodes is another codes lah. Okay, another alphanumeric codes. Okay, since the ASCII is sufficient for using computers in United States. Okay, only support United States punya karakter, but not for other regions. Okay, contohnya kita ada currency sign. Okay, such euro, pound sterling, yen, and then you have the special characters seperti Arabic characters, and you have the Japanese characters, Chinese character, okay, and then Russian character, etc. So what happened here is another code was introduced. Okay, that is we call it as a Unicode. Okay, so Unicode is 32 bit standard. Okay, size dia 31 bit. Okay, quite besar. Okay, that allows more than 110,000 characters. So it we can support up to this. Okay, kalau kamu tukarlah 2/31, okay, kamu akan dapat lebih daripada 600,000. Okay, can you press the calculator? 2/31. Berapa dapat? Saya tak ada calculator lah. Tu kuasa. Siapa ada calculator? Boleh tekan tak? 2 kuasa 31 dapat berapa? Berapa value dia? Okay, banyak lah. Okay, it can support up to
Lebih juta ni.
thousand or billion numbers.
Billion.
Okay, but now Unicode sekarang ni dah okay, lebih, saya rasa dah lebih dah daripada 100 ribu
Lebih.
110,000 characters ni. Dah banyak dah sekarang ni. Sebab this Unicode is keep updating setiap hari. Okay, if ada je characters, dia akan keep updating. Okay, so this Unicode can support most language in the world. So each character is assigned a code point written in hexadecimal. Kenapa hexadecimal? Kenapa tak guna binary number? Sebabnya 31 bit. Bayangkan kamu nak tulis 31 bit 1011 31 sebanyak 31 kali. Okay, 31 bit. Quite panjang. So kita simplifykan dia guna hexadecimal. Okay, di mana kamu bahagikan dia macam ni lah. Okay, so this is a represent 32 bit. Okay, sebab kamu tahu case 8 bit sama dengan 1 byte. Okay, 16 bit sama dengan 2 byte. Okay, so sekarang ni yang ni baru ada, ni is 1 byte, yang ni baru ada 2 byte. Okay, kalau 32 bit, okay, kamu ada 4 bytes. Okay, which is kalau hexadecimal 4 byte ni dia macam ni lah. Kalau kamu tulis, contohnya saya ambil FF A B C D 12. Okay, so this is the 32 bit punya numbers dalam hexa. Okay, yang ni baru 16 bit ni. Okay, kalau 8 bit tadi, contoh kamu ada 8 bit number 10111100. Okay, tukar dalam hexa baru ada 8421. Okay, yang ni 8412, 12 is C. 8910, okay, baru dapat 2 ni character of hexa, baru BC. So this is only 8 bit. Okay, kalau 4 character of hexa 16 bit. 32 bit, so you need to have 4 character of hexadecimal. Okay, so this Unicode is constantly changing as more character getting added. Okay, contohlah, this is Arabic. Okay, to display alif. Okay, so dia ada banyak pula ni. Okay, general Unicode isolated at the end. Sebab kan kita bila kita buat apa ni Arabic punya characters, kan dia akan ada macam mana alif tu bila kat ujung, kat depan. Okay, so dia ada macam ni lah. Bar ni pun sama juga. Okay, bar tu dekat ujung, kat depan, kat mula-mula. Ataupun bar tu sorang-sorang. Okay, so it have many. So untuk represent alif, okay, so this is the punya code lah dalam Unicode 0627. This is dalam hexa lah. Okay, every time you press the alif here 0627, so it will display this alif. Okay, kalau FE 8E, so dia akan display alif yang dekat sini. Alright, so this is a contoh. Okay, so that's it for chapter 2. Any question untuk chapter 2? Okay, kamu dah belajar macam mana nak buat number conversion, and then after that you already know how to do a digital codes. Okay, ada 4 digital codes yang kita belajar tadi, which is BCD codes, Gray codes, ASCII code, and Unicode. Actually, there are a lot of codes lagi yang banyak kat luar, tapi this is the most code yang digunakan lah. Okay, ada soalan? Okay.